here we're making potato soup. So the student places 0.5 kilograms, so that's obviously our mass, of potatoes in a pan of water. It's very useful to identify your components of the equation as you're going through the question. During the cooking, the temperature of the potato went from 20 to 100, so that's a difference of 80 degrees Celsius. The specific heat capacity is 3,400 joules per kilogram per degree Celsius. It gives us the equation here, so you won't always be given the equation, but it's nice when it happens. And it wants us to work out the change in thermal energy. So let's see, we've got our mass of 0.5, our specific heat capacity of 3,400, and our temperature change of 80. When we multiply those together, we will get 136,000. That's 136,000 joules. So we need to make sure we write that in the answer box. So why is the energy supplied by the cooker greater than that? So whenever we're heating something up, not all that heat remains in that object. Some of it will heat up the air around it. So we say the energy is dissipated into the surroundings. Just like if you leave a cup of tea on the side, it eventually gets colder. That's because that energy inside is being transferred to the surroundings itself. If you put a thermometer just outside the cup, it would detect a very small temperature rise as your cup of tea got cooler. So there's just one way that we could reduce the time. So let's look at their diagram and see what they're doing. So they've got a saucepan, putting potatoes in it, and they're leaving it like that. So normally when you cook something in a saucepan, you put a lid on it. So that stops the steam from escaping, and it keeps the inside warmer. Because every time the particles escape as steam, they're taking some of their energy with them. So if the energy is leaving us in the steam, you're going to have less energy left in that water. So now we've cooked the potatoes, we have a food processor to blend it. So put our potatoes in the jug and it spins. We have the input of 500 watts and the useful output of 300. You need to be very careful with these questions. If it gives you the useful output, it's fine. But if it tells you the wasted, then you've got to work out the useful. So in this case, the wasted would be 200 watts. We don't need it for this question, but if it told you the total and the wasted, you'd need to work out the useful for this question. So efficiency is useful power output over total power input. Again, we've been given the equation, so just do 300 over 500, which will give us 0.6. So that is equal to 60%, but you can just leave it at 0.6. And your efficiency should always be between 0 and 1, or 0% and 100%. Nothing can be better than 100% efficient, unless it's getting more energy than it had. So we had our jug, and it was made from plastic. So plastic, we should know, is an insulator, and it has a low thermal conductivity. That just means it doesn't give out much heat when there's something hot inside of it. Explain why this is an advantage. Well, by being an insulator, it has a lower rate of energy transfer. So if it was a conductor, the energy would go really quickly, but as it's an insulator, the energy goes slower. So we say it's a slower or a lower rate of energy transfer. That's 1 mark out of 2. So we've said what it does, but why is that an advantage? Well, it keeps our soup hotter. So our soup remains at a higher temperature.